is XO is mu equals 0. The alternate is mean does not equal 0, and the population standard deviation is not known. Jordan collects a sample size of 9 and computes D equals 2.2 and SD equals 3.3. What is the value of the test statistics? You have to subtract those two, I think. So 3.3 minus 2.2. I think is what it is. But maybe not.
I have the equation for to find the test statistic.
Or the confidence interval. You have the formula for the what?
The test statistic.
Okay, what is it?
So it's T equals, kind of hard to say, but in parentheses, D minus O divided by SD divided by the square root of N. It was in our textbook, if you need to refer to it.
Okay, so D is 2.2 minus O.
Mm-hmm.
What's O?
Have to go look up back what that is.
It was in the textbook?
It actually might be 0, not O. I'll look right now. I saw that from the video, but it's probably in the textbook too. Let's see, test.
Okay. I thought I understood this one fairly well, but
Yes.
where do you see that the mu equals 0?
Okay, I'm gonna go look back in the video from the preparation and go look at it. 1 sec.
Is that from the video where the TA does it, or from the actual professor?
This is the one that was listed for more help,
Oh,
like in our individual preparation.
Okay.
Give the relevant summary statistics. Oh, never mind. I'm reading through the book right now, or the chapter.
I'm looking at chapter 2.
If you guys look in the individual preparation, go to lesson 12, part 1, and that's where I found it.
Okay.
So the test statistic, what is the?
Oh, I see. Yeah.
Oh, this is Brother Kumar from the math department, and these videos will be.
Is it 0?
Then I'll talk about hypothesis.
See, that's what I'm thinking.
Then I'll follow it up with confidence.
It seems like it'd be weird that they minus 0 because it would just be 2.2 though.
So first
Yeah,
of all,
that's kind of
here are dependent samples. So paired dependent samples is where individuals in one sample are used to determine the unit for individuals to be in the second sample. So an example that I have is our son's taught in 3 random, then that, for instance, the example down here, and with, or 2 opposite units can be paired together. Here's an example. We have he is example, or it's already pretty. Now,
Did you find it?
in this case, in the slide, where
So I think it's 0.
the steel and there's battery and steel
Go to like
fire and second.
2 minutes and 48 seconds.
248?
Yeah. Do you see that?
They're actually very similar. This is the test statistic for one sample T, which is from the last lesson.
Yeah.
We take our sample mean minus the null hypothesis divided by a standard deviation, which is in this case our sample standard deviation divided by the square root of n. Now, if we compare that to a matched paired sample T test, we take d bar, which is the mean of our differences. Okay, and so
Wait a minute. The mean, which is the mean of the differences? Which is the mean of the differences. D bar is the mean of the differences. So
That's to get a difference. We get d bar, which is the mean of our differences. Okay, minus 0, and 0. We'll talk about this in just a sec. 0 is our null hypothesis. I'll show you why in just a moment.
So it is 0.
So we take the standard deviation of the differences over the square root of our sample size.
okay, so D is the mean of the differences, but do we know the mean of the differences?
I think we have to do this in SPSS.
Yeah, but we don't have the information, do we?
yeah. It says what D.
It says what?
It says what D is. What's the actual?
Okay, so it says, so it's 2.20 minus 0 over 3.3 divided by the square root of 9, right?
What was the equation for it?
T equals, in the parentheses, D minus 0 divided by SD divided by the square root of n. So the D, it says in the problem that D is 2.2.
2.
2.2, yeah, and SD is 3.3. So it would be 2.2 divided by 3.3 divided by the square root of 9. Is that right?
It's 2.2. 2 divided by
Probably obtaining a test statistic greater than Jordan's.
So I got 0.222. Is that what you got?
Wait, what?
222.
222.
The next one is the probability of attaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test. So do we use the applet?
What was it? 0.403?
Yeah. We can use that applet, right? And we put in
I
the area.
think so. Yeah.
Wait, what's the? Because I have had the learning up to this point, when they go back, I don't have it like set in my brain, you know. It's like figuring out what the p-value is.
Well, I think p-value is when you put it into the SPSS, it's the sig.
Yeah, it's like the two-sided.
But in this case, I think we have to use the applet that is at the top.
Mhm.
See where it says, here's a link to the T distribution applet.
So do you put the 0.04 in the area?
I think so. But you also have to put in the degrees of freedom. But it's the same regardless. So it's either, I'm thinking it's either, see, I don't know if it would be positive or negative though.
3.472.
Yeah, but do you think it's positive or negative? Does it say the probability of the test statistic greater than Jordan? It shouldn't be a negative. I think it's the 3.472, I think. Okay, then use the data file to answer the next 6th question. Perform a paired sample t-test. Be sure that the test does group 1 minus group 2. Use a null hypothesis of 0, and it's not 0, and 11 significance is 0.10. So I'll go ahead and pull that up.
So in the lesson 12, gives you instructions to do that in SPS, I think.
It does.
Yeah, I did.
What? Oh, okay, IBM. Okay, I'm pulling up my SPSS right now.
Variable.
Have you guys gotten it pulled up yet?
Mine's
It
still
takes
loading.
forever. Mine too. It takes forever.
It's so slow.
I pulled mine up before because I didn't have
One thing that I cannot understand is how do you know if it's a one-tailed or a two-tailed test? I'm not sure on that. I think it did tell us. Let's see. Let me see if I can find it in my notes. Okay, if it's the alternative is if it says it's not equal to something, then it's two-tailed. If it's less than or greater than, then it's one-tailed.
Okay, that makes sense.
So it says if there's a a not equals to sign, then it is two-tailed. Okay, so
And then the greater than was one-tailed.
okay. Okay, so I pulled mine up, and how you do this is you go to
Transform.
transform, and then to compute variable. And then it said to make sure that we subtract group 1 from group 2, right?
Yeah.
Mhm.
So we put in group 1 first, and then we put in the minus sign, and then the group 2, correct?
Yep.
And then you push what?
Make sure you type in the target variable difference. I don't know. That was something.
Oh yeah, the target variable is 0.
Wait, it's 0?
Because isn't that the null hypothesis? Like we're trying to find out if it's 0 or not 0. Isn't that right?
I think that's just labeling what this thing is going to be. So target variable.
Oh, right. You're right. So what are we trying to find out?
You just like hit OK.
I'm just going to put difference. And then push OK.
Right?
Okay, so now we have the difference.
Mm-hmm.
So now we go to data. I mean analyze, right? And then compare mean, and then the one
Sample t-test.
sample. And we want to put in the difference, right?
Yes.
The test variable is the difference. Okay, so the t is 0.407. Is that correct?
Mm-hmm. Is that the test statistic?
Can you read to me what the question for number 5 is?
What is the test statistic? Round to 3 decimal places.
Okay, I think that's 4.407, right? And the p value would be 0.689 because it's a two-tailed test. So we leave it the way it is.
Because if it was 1, it'd be divided by 2, right?
Right. And what is the correct decision based on the hypothesis? I don't know.
The null hypothesis?
Well, it means it's not equal to 0. So
what I have from the book, it said reject null hypothesis if the p-value is less than level of significance. If not, then don't reject.
okay, the level of significance is 0.10, and this is 0.68. So 0.68 is greater than.
So then it would be fail to reject, right?
Let's see.
Wait, the null hypothesis
is low,
is equal to 0.
It's fail to reject because p is greater than the level of significance. So we fail to reject. Is that right?
Yeah, based on what the textbook said. Or what the video said.
Let's fail to reject. So number 5 is 0.407. Number 6 is 0.689. I hope. Step and 8. Suppose your alternative hypothesis is instead the mu is greater than 0. What is the correct decision based on this evidence? That means, well, doesn't that the mean of the differences?
This wording really confuses me sometimes.
Yeah, the mean of the difference according to the table is 31.025.
So then would it be
So-
we have sufficient evidence that the mean of the difference is greater than 0?
Yeah. So we have sufficient evidence that the mean of the difference is greater than 0.
Yeah.
I think.
Yeah,
You guys think?
yeah, that's what I think.
Man, that wording is so close. The little in, like sufficient and sufficient.
Yeah.
Yeah, because if we don't reject it, then we use the insufficient, but if we do reject, then we use the sufficient. If that makes sense.
Yeah. Okay, so you got C, right?
Yeah.
Yeah.
Okay. So use the next one. Oh,
This is still the database.
One.
Yeah.
Okay, so let's open that up.
So this is also two-tailed.
Okay, I haven't even gotten there yet. Hang on just a second. I'm just putting it in the, okay. So this says is equal to or not equal to, and this is 0.01. Okay, so so it's a two-tailed, right? Okay.
Mm-hmm.
Perform a paired samples t-test in SPSS. Group 1 minus group 2. This data comes from something. The null hypothesis is the mean of the difference is 0, and the alternative hypothesis is the mean of the differences is not 0, and the level of significance is 0.1. Which is greater, the sample or the, I don't know, how do we know that? Well, we got to look and see how many samples there were. There were 22 samples, right? Or were there 44?
Let me look. There's 22 samples.
There's what?
22.
22 samples?
Mm-hmm.
And not 44?
I don't have 44. Well, I guess between group 1 and group 2, we have 44.
Yeah, so do you think there's 44 samples or do you think there's 22?
Ooh.
Because there are two groups of, there's
22.
Group 1 and group 2. So if group 1 is zebras and group 2 is giraffes, there would be 22 zebras and 22 giraffes.
So we're on 9, right?
Yep.
Yeah.
Okay. My mind is fried. Okay. So I would say that there's 40.
Okay, so let's figure out what the DF is first. What's the DF? What's DF mean?
Yeah, that's the thing. It's like,
I know.
Oh, that's the degrees of freedom.
Oh.
Okay,
makes
so if I analyze this and compare the means with the one t-test,
21 degrees of freedom. Sorry.
okay, so group one is, so it would be,
What's
samples or more?
yeah, so N is more.
Yeah, because it's either 22 or 20 or 44. Right?
Yeah.
Mhm.
Now, were we supposed to, I see it where you got the degrees of freedom in group one and group two, but were we supposed to do the differences first and then
Yeah.
do?
So it's be sure to test. The test does group minus group 2.
Okay, so let me do the transform compute variable. So you go
I already
group
did
one.
that. The same.
Okay, so it's the same. Okay.
Yeah, the N was 22, the DF was 21.
Okay. Same thing. Okay.
And the p-value is the same, which is 0.001.
Okay. 0.000.
001, right?
Yep, that's
Oh,
what I have here.
001. You have 001?
Yeah. Wait, what do you have, Alexis?
I 0.001.
Where did you get 0.0 from the table? Because mine says 0.000. Maybe I let me try something else. Maybe I'm looking at the wrong thing. Hang on a second.
You're fine.
Okay, so I'm going to do this again. So I go to transform compute variable, group 1 minus group 2, and I push OK. Why am I not getting this?
Are you typing in a place?
Okay, compute variable. How come I have different? Do we put in the difference?
Yeah, so you put in that part.
Group 1 minus group 2, and you push OK, correct?
Yeah.
And this says change existing variable. Shoot, I'm going to have to do this all over from the beginning, I think, because, okay, I'm going to do this from the beginning. Sorry, guys.
No, you're good.
Oh, you're fine.
Because I am not quite getting this. Okay, why don't we just keep going for a second while I...
Okay.
Do you guys have 0.001?
Yeah.
Mhm.
All right, so
If the p-value is less than the A,
Then we reject it. If not, then we don't reject.
okay. So
Okay, so the difference, okay, I got the difference. Then I go to analyze, compare means, 1t sample. And do I do the test variable as the difference, right? Okay.
Yeah.
Okay, I got it now.
Woohoo!
Good.
Yay.
All right, so then question 11, what decision you make? Okay, so our hypothesis is point what? 0, 1? I mean our
Level of significance.
0, 1,
Uh-huh.
and our p-value is 0.001, which is a lot less than 0.01.
So then it would be reject, right?
So if the p-value
Is
is
less than the
less-
level of significance, then we reject.
then you reject.
Yeah.
O must go. So you reject the null hypothesis. Okay. Okay, you decide to try another alternative hypothesis. Time you use that the mean of the differences is greater than 0 and you keep the same level of significance. Did the p-value increase or decrease? Okay, so if the difference, if the mean of the difference is less than 0, then the p-value
It's greater than 0.
is greater. I meant greater than 0.
Okay.
Then it should increase.
That's what I would think.
So if it was greater than 0, then and the alternative hypothesis was greater than 0, then it would be keep the guy or fail to reject.
Yeah.
Mm-hmm.
Oh my goodness. Okay.
So many questions.
Yeah. Questions today.
Based on your response from the previous question, what conclusion did you make? Okay. If it's
Isn't it insufficient evidence?
we have insufficient evidence that there is no mean difference between the two groups, or we have insufficient evidence there is a mean difference between the two groups. Okay, so we have insufficient evidence because when we when we fail to reject the null hypothesis, then we have insufficient evidence
Uh-huh.
that there is a mean difference. So
So now we have to pick between the two.
I think it's D.
Okay.
I think. Okay, as we have seen, the p-value depends on the alternative hypotheses. In general, which alternative hypothesis will give the smallest p-value?
It would be a one side tail, right? Because we divide by 2.
Yes. So then it would be that it is less than 0. That the mean of the difference is less than 0.
Oh man. I guess we can each try a different one and make see.
Okay. I'll try B.
I'll try A.
And I'll try D.
Okay. Okay, determine the 95% confidence interval for the mean difference between the two groups using group 1 minus group 2 and input your answer. So we have to go back to our table.
Mm-hmm.
So the did it ask for lower and upper?
Yes.
So the lower of 95% is 5.303 and upper is 18.607. Is that what you guys have?
Wait, that's questions 18 and 19.
Uh-huh.
Oh. Where am I? Oh, I went down too far. Sorry.
You're fine.
Determine the 90% confidence interval for the mean difference between the two groups. So you go back to that table and find the mean difference. And the mean difference is 11.955. Do you guys see that?
Uh-huh.
Yep.
But you know what else though? Oh, well, that wouldn't matter. Okay, so I think it's 11.955 on number 16. What is the margin of error? Okay, let's go down to 18 first, because the upper one is 18.607,
Mm-hmm.
and the lower bound on 18 is 5.303.
Yep.
The
Yep.
upper bound, 18.607.
Yes.
Yep.
Okay, so we need to find the margin of error for this confidence level. Okay, so the confidence, so that I have the formula,
Mm-hmm.
which is P, which is the test value, divided by S, which is the sample standard deviation, divided by the sample size. Do we know what the sample size is though?
44 or 22.
22. Okay, so do we know the T means the T on here, right? So that's 3.737.
So the is T
Times the sample size, the standard deviation, which is 15 point, whoops, darn it. Standard deviation is 15.003 divided by the square root of 22. I have 11.953, which is exactly the mean, which is what it says is the mean difference.
Huh.
That's weird.
Well, I'm going to put that. I'm going to go ahead and submit it, okay?
Okay.
And I'll let you know. All right. Number 3 is wrong. Number 4 is wrong.
Ah,
Okay. So number 3 is wrong. Number 4 is wrong. I'm going to keep going.
Okay.
Number 5 is correct. 6 is correct. 7 is correct. 8 is wrong. 9 is correct. 10 is correct. 11 is correct. 12 is wrong. So that would be, we know that's going to be
Decrease.
decrease. Number 13 is wrong.
What?
My gosh. 14 is wrong.
what did we have for
15 is wrong. 16 is right. 17 is wrong. And 18 and 19 are correct.
So for number 15, what did you put?
Okay, for number 15, I put B.
C?
I put B.
Oh, B. Okay. I think it might be D.
Okay. Okay. So we got to find out these other things, though. 14. We all put D, right?
On 14? Yeah.
Mhm. So
B?
I don't know now because we got the
Oh, that
12
one's
and 13.
wrong.
So I'm thinking it must be that we have sufficient evidence.
That there's a mean difference.
I think so. Okay, let me try something.
What if number 15 is not enough information? Because can we really know by no information?
we'll be able to figure out for these multiple choice ones because we all have one chance to turn it in one. So, but
Okay.
I don't know.
I just want to understand it.
Yeah, but we're too stupid, apparently, to
Too
figure it
stupid
out.
about being taught correctly. I'm sorry, but
Because in my,
our program, we're lazy and we don't care if we succeed or not.
in my opinion, like what they're teaching us in the videos are not really covering what's on this quiz.
Yeah.
But okay, what was that? The one where we got 3.42. Oh, that was wrong too.
On what
Okay,
question?
On question 4, we got that wrong, and that's where we use the applet.
Oh.
We got question 3 wrong too, though.
Yeah. So I'm going to go to see if anybody posted a video. Let's see if anybody that's not getting paid can help us. Okay, let me see if I can figure one out. Oh my gosh, no thanks.
Maybe tonight, but like tonight's like
That one is 1 hour and 45 minutes.
Whoa.
So we probably won't listen to that one. Okay, let me see. Okay, let's see here. This one's 36.
And then the T.
Yep, and you're on student probability, right?
Yeah, students probability.
Okay, and so you enter 2.0.
Yeah, 2.0. Oh, wait. Yeah, oh yeah, 2. Yeah, 2. Because that's.
And then you
Okay. 0.003. Use this probability to determine the p-value. Conclude a computed test.
Just a second.
Always forget what the new thing is. Population mean equals 0. The alternative hypothesis is that it doesn't equal 0. Population standard deviation is not known. So we collect a sample size of 9 and compute that the distance is complete to and the standard deviation of the distance is.
Wait a minute.
3.
That's not even, uh-oh, crud.
I got 2.
I got 2 as well.
That's correct.
Sweet. Then the probability of obtaining a statistic greater than.
You know what? That wasn't even. We're in lesson 12, right?
Yeah.
So, do you guys see that?
Uh-huh.
So I put 8 for the degrees of freedom because it's 9 minus 1 or 1. And then I put 2 for the t value because we got that in the question above it. And see how the area is that 0.403, which is also what it says right there in the question. Oops.
Sorry, guys, hang on. Well,
So, you guys see that?
Uh-huh.
So I put 8 for the degrees of freedom because it's 9 minus 1 or 1.
oh,
And then I put 2 for the t value because we got that in the question above it. And see how the area is that 0.403, which is also what it says right there in the question. Oops. So would greater than be both of these together or just this one?
Well, if 2's positive, I would think it would be just to the right.
Yeah, but it comes up with the same.
But it's a question asking us to use a different p-value.
Well, it's used this probability, which is this number, to determine the p-value. That's where I'm like, what?
So where are we putting the probability?
I don't even know what formula to use.
I looked back through my stuff and
did you hear them?
Yeah.
You don't know what to do.
They must be stupid too, apparently. Okay, let me try one more. So let me see if I can, these people seem to know what they're doing. But they're hard to hear.
Missed number 4, but I guess we're starting with number 3, so it doesn't matter, right?
yeah, I actually did it already.
Okay.
I can help. I got 2 wrong.
Yeah, I missed 3 of them, and I don't know. So I'm like, somebody's gotta help me. That's what
I know question 4, so
Okay, good.
I did it yesterday. So very good. So I guess question 3.
Here we go. Can you hear them?
Yeah.
x after minus x before. So null hypothesis is that what scale are you using? It's population. Mean equals 0. The alternative hypothesis is that it doesn't equal 0.
I love her accent.
It's not. If we collect a sample size of 9, compute that the distance is complete to and the standard deviation of the distance is 3.3. What is the value of the test?
I got 2.
I got 2 as well.
That's correct.
Okay, 2. They got 2.
How did they
Let's
get that?
let's see if we can figure that out. So, I have to go back to the quiz because I accidentally erased it. So I have to start my quiz over again. So this will be my next attempt. But the last people, if I am correct, what they did on that first one is they went to the applet, and it does say in our formulas that you have to do to get the degrees of freedom n minus 1. So if n is 9, so n minus 1 would be 8. So when you go to the T up there where it says degrees of freedom, you put 8, I believe, and then you put that area of 0.0403. That's a 2.440. So then what was that formula we used before? Was 2.2. So maybe we use 2.444 over 3.3. Let me try this. Okay, let me. Okay, I'm going to go back again and listen to him, okay?
Okay.
And the distance is 3.3. What is the value of the test?
I got 2.
I got 2 as well.
That's correct.
2. I have no idea how they got what the test statistic is. That would be good to know, wouldn't it?
Yeah.
Okay, let's go into question 4.
Sweet. Then the probability of the statistic greater than 4 is 0.003. Use this probability to determine the p-value of the group of computed test.
Okay, so I need you to explain to me what we did. I can correct.
So we use the thing.
Yeah.
Again, and you use the p-score and the
And you're on student probability, right?
yeah, students probability.
Okay, and so you enter 2.0.
Yeah, 2.0. Like, yeah, 2. Usually, yeah, 2, because that's the
Okay, and then you
and then
line.
then you have to do the degrees of freedom, which
Yeah.
the degree of freedom is sample size minus 1. So sample size was what, 9?
Yeah. Or
So
that, I thought the degree.
I got 0.081, and that's right.
Oh, you don't divide it by 2?
No.
Yeah, and I divided it by 2 because it's a greater. So I was like, oh, it's 1/12. Okay.
Yeah, no.
So if I would have just left it, then I would have been fine.
Yeah.
0.0805, but you said it's 0.08.
0.089.
So it's 0.081.
Yeah.
0.081. Okay, so I'm going to go back to the applet, and I'm going to put 8. And what do you put in the area though? 0.0403. And the T is 2. Oh, okay, I got it.
Yeah, that makes sense.
Wait, what do you do with the degrees of freedom?
Okay, so go to the applet.
Yeah.
Okay, at where it says degrees of freedom, there is a formula that says when it's n minus it's degrees of freedom, or it's n minus 1 is the degree of freedom.
Yeah.
So n is 9 minus 1, so you put 8 in the degrees of freedom.
Mm-hmm.
We know that our test value, because is 2, so you put 2 down there in the box.
Yeah.
Is E, and you press enter, and up in the area, it's 0.081 when you round it.
Yep. I guess because it's 0.0805.
Yeah, so you round it to 0.081.
There we go. At least
That
we're
makes
ourselves.
0.081. Okay, now you guys are going to have to help me on this because I accidentally
You're fine.
erased it. So question 3 is 2, question 4, 0.081. And then question 5, what is the test statistic? What do we get for that?
407.
0.407.
We got that one right.
And number, yeah.
Okay.
Because I didn't write down correct answers.
Okay.
Because I accidentally erased. And then question 6 was what?
Wait.
0.689.
0.669?
89.
0.689. That's right. Okay. And then on 7, we got that one right. What was that?
Failed to reject.
Okay, we got that one right. And then we did not get number 8 right. So if we fail to reject, then we have, if we fail to reject, then we keep the guy, so we have sufficient evidence.
I think it's
So
D.
we have sufficient evidence that the mean of the differences is equal to 0. Because we want to keep the hypothesis. The hypothesis, wait a minute, is greater than 0.
What did you put before though?
I erased it on accident. But it was, we did insufficient.
Okay.
So I think it is C. What do you guys have? Did you guys put, which one did you put down? What do you have on number 8?
I have C, but I'm not sure if I fixed it after
Right?
you told
That's the exact same thing I was thinking. Like when you went through and were telling me, like, oh, well, maybe it's this.
Yeah.
I think it might be C because we failed to reject the null hypothesis, and the null hypothesis is that the mean of the differences is greater than 0. So we have sufficient evidence that the mean of the differences is greater than 0.
Okay.
So I think C. I think. Oh well, I mean, Okay, number 9 we got right.
Was
And
N.
that was the N. Okay, and number 10 we got right. And that was,
0.001.
okay. 11 we got right.
Reject the null.
Okay, and 12 we got wrong, but so we
It's
should
decrease.
put decrease. Okay, and 13 we got wrong, so it's actually reject.
Mm-hmm.
And then 14, so when we reject, if 13 is reject, that means that
We have sufficient.
we have insufficient evidence that the mean is greater than 0. We have insufficient evidence. So we are rejecting it. So we have insufficient evidence. Oh, I don't know. What do you guys think?
Reject. I thought if we reject, then we have sufficient evidence. I thought if we don't reject, then we have insufficient.
Okay, if we reject the null hypothesis, then we reject the null hypothesis. I mean, the HO must go.
Uh-huh.
So if we rejected it, right? So so it means that we have insufficient evidence, right?
Cassie,
What did you guys put down for 4?
Again, I think I went in and changed it. So I have at this very second C.
Okay. I wrote down on my piece of paper C with a question mark. Okay, we got 15 wrong, but we know it's not B because that's what I put down. So we're thinking that there's not enough information.
well, I feel like we need more information to be able to answer that. But I'm not
Okay.
sure.
Okay. Then 16 we got right. What was that?
16 was 11.955. Right, Cassie?
Yeah.
Okay.
Okay, then we got 17 wrong and 18 was correct. What did we have for 18?
5.300. Sorry, 5.303.
And then 19 was correct.
18.607.
Okay. So 17, the margin of error for this 95% confidence interval. And to get a confidence interval, it says t times the standard deviation divided by the square root of the sample. So isn't T like the T 3.737? Oh, you know what? I'm going to listen to what they say on here, okay?
Yeah.
And that's on number 17, so we're going to be all the way down here somewhere. Okay, let's listen to them.
Because we could do the Excel, we could all put our data into that.
So what population would this be?
The population will be, depending on how many stores you go to. Right now, 20, right? That
Okay, that's what you're, okay. For some reason I just I'm like,
yeah, if so, like 2 of us could just go to 2 different stores. Like, 2 stores. Yeah, because we have
Oh, they're talking about their project.
How much would it?
Oh,
And like the sample size is 9, the sample size -1, so 9 minus 1 is 8. And then the t-square that you just got in the bit, like, right that, and then you just kind of put the left side of it, you just remove the left side.
so yours, Margaret, if you're just doing what I'm doing, I had to put both outsides and it gave me the area of 0.805 and we rounded up.
Oh.
But I didn't round, I had to do it again, rounding up.
Right.
I screwed up and put the left side, or did my mess up. I only did a 1 tail.
Else. But what if it's an equal sign? I wrote that in my notes. If it's an equal sign, then it's or if there's no equal sign, you know, it's equal sign.
Okay. Awesome. Okay. Well, we wanted to talk about, we were going to talk about.
Does the number I give you work?
Okay.
11.955.
11.955. What number is that?
That is 16.
Okay, so they must be getting ready to talk about 17.
The margin of error was 6.6.
I said, I got that one wrong, and then I emailed the tutor, and she's like, oh, it's upper bound minus lower bound divided by 2. I was like, dang it. Oh, did you hear that?
What is it?
Upper bound minus lower bound divided by 2.
Oh.
Okay, upper bound 18.607 minus 5.303 divided by 2. 15.956. Okay, now a second.
Yeah,
I
that's
thought that it was so easy because I was on the homework I screwed up on.
So what was? I'm sorry, guys. What was the answer?
question.
For number 17.
17 is 6.6.
6.652.
What?
How is it 6.652?
And then the lower bound, the upper bound, they're right there. Oh, yes. Yeah.
Just this. So I didn't get 15 right.
Oh, okay. It's not enough information depends on the following. I spent 8.
Did you hear that? 50
Yeah.
was not enough information, just like what we said.
Oh, cool.
Less than. That's my husband's right. Your greater and your less than are exactly the same on your probability.
Yeah, that's what. Yeah, I figured out. It took a while.
They're 17. What they got for 17
Yeah.
is right. You just have to do it separately. Again, if you type it all in, it's probably funky. But I got there 6.652. You just have to do it separately.
So what's the answer?
Okay, so
So you go
607 minus 5.303 equals that, and then divided by 2.
yeah
Oh, okay.
6.652.
Oh, gotcha. Okay, got that.
6.652. Okay, who wants to try to submit this one?
I will.
Okay.
All right, let's see what we get.
1 second. Okay, we got 2 wrong, and those were 8. What did you guys put for 8? Was it C?
We put C.
Yeah, it's not C. And then the other one we got wrong was 14. What did you guys put?
I put C again.
So I put A, and that was not right.
So it's not C and it's not A.
It's not
So it's
C.
got to be insufficient. It's not. Is that what you said? It's not C.
Cause I put A, and it's not right. So if you put C before, and it was still wrong, then yeah.
Did you put C before though? So I haven't turned mine in yet at all. So let's see, we got 8 wrong. You put 8, right?
Yeah. So 8 is not C.
Maybe we have, I don't know. I'll put D
Okay.
for 8, and then for 14, I will put, did I keep C?
Sure, keep C.
Okay. And I'll turn that in. Eight is not D.
8 is not D or C. So it's got to be insufficient.
But 14 is
So we
C.
have 14 is C. Okay, so 8 is not C or D, correct? So we have insufficient evidence that the mean of the difference is greater than 0. I'm going to put B. So I'm going to submit mine for the last time. So if you
Okay.
guys have a thought,
Yeah, I'm bringing
And-
up another page right now.
okay, I'm submitting mine. So let's see. Oh, yep, they're all right. So 8 is B,
D.
and B is in boy,
Okay.
and 14 is C is in cat.
Okay.
Right.
Oh.
No, you just go put it all back in there again.
I'm going to put upper minus lower bound divided by 2.
Yes.
Woo.
All right. Ridiculous. Again, but okay.
We're done.
Okay.
So
All right.
tomorrow.
Hang on a second. I have another class meeting tomorrow. And hopefully, maybe tomorrow we can talk about our project. Okay, I'm good. So tomorrow at 4:30?
Is 2:30 still good?
Well, I'm sorry. 2:30 for you guys, 4:30 for me.
Oh yeah.
Okay.
I
Perfect.
keep forgetting to say that. Okay, so tomorrow then at 2:30.
Perfect.
Bye.
Bye.
Yeah.